Okay, the last unit or the last section in this unit is going to be solving rational equations. We've done multiplying, dividing, adding, and subtracting. And this one's going to be similar to the adding and subtracting. So if you look at the top, I have two methods for numbers 1 through 4. I'm going to make a note of it up here. We're going to do method 1, and then from the rest, or for the rest, 5 through 9, we're going to do method number 2. So anytime you have two fractions and you're trying to solve it, just like 1 through 4, we're going to cross multiply. So I can do, I'm going to try to do it. So like this, if you multiply, it doesn't matter which direction you start. So 7 times x is just going to be 7x. Put your equal sign, and then you can go the other direction. And then this is 4 times x minus 6. So that you don't have to write this down, but that just means you have to distribute when you multiply that part. So this is going to be 4x minus 24. And then once you write that, you just solve it. Depending, you might have a linear equation or quadratic. Just get the x by itself. Here I'm going to do minus 4x. And then divide by 3. So this is a possible solution. You always want to check your answers by plugging them into the original. So if you were to use, and I'm not going to show the calculator for this, but if you were to do it, you would do 7 over negative 8 minus 6 is equal to 4 over negative 8, and it would give you true, which means your answer would be negative 8. So that's how I'm going to do the next 3 problems. So on number 2, we're going to do, I'm going to start this way. R times R is R squared. Put your equal sign. And then this direction means that I'm doing 4 times R minus 1, which is 4R minus 4. If you have a squared in the problem, that means that you want to get everything on the same side. So I'm going to move these two because I want the R squared to stay positive. So this is going to be R squared minus 4R. The minus 4 is going to become plus 4 is equal to 0. By now you should see this and immediately think that you should be able to do X method on this. And I'm not going to show X method. You should be doing it on your paper. But at this part, you get R minus 2 and R minus 2. And then you have one possible solution. Since both parentheses are the same, your only possible solution is 2. And then you would, to plug it in, you would do 2 over 2 minus 1. Just plug it into anywhere you see an R. 4 over 2. And this should be true. And that would be your answer. Let me zoom this in. Number 3. So we start off with those two. So if you do m plus 3 times m minus 2, make sure that you don't put m squared minus 6. This is X method. I mean, sorry, this is box method or FOIL. And I'm going to use it doing box method. So you have m plus 3 on the top and then m minus 2 on the side. So here we have m squared, 3m, negative 2 times m is negative 2m, and then 3 times negative 2 is negative 6. And you should always be able to combine these two. So that means that we can write m squared, negative 2m plus 3m is positive 1m, minus 6, put your equal sign, and then you're going to do the other direction, which is 3 times 8. So 24, and then before you do X method, make sure you have a 0 on one of your two sides. So here you want to move the 24 before you start doing X method. So we get m squared plus m minus 30. And then from doing X method, we get m plus 6 and m minus 5. So 2 possible solutions here. One of them is m is equal to negative 6. The other one is m is equal to positive 5. And whenever you plug these in, you have to plug them in individually. So the negative 6 would look like this, which would be true. And then for the 5, you would do 5 plus 3 over 3 is equal to 8 over 5 minus 2, which is also true. And then the last one for this method is number 4. So we go this, well, I'm gonna go this direction, which is the same thing as this. And that gives us y squared plus 5y, put your equal sign. And then this direction is 3 times y plus 8. When you distribute, you have 3y plus 24. And same thing, as soon as you see a y squared, move everything to the same side before you start doing any x method. So minus 3y and then the 24 subtract it or just move it, which makes it negative. And then now that we have a 0, you can do x method. And we get y plus 6, y minus 4. So the two possible answers are y is equal to negative 6 and y is equal to positive 4. You plug these in. I'm not going to write it out, but if you plug these in, they both give you true. So they both should work. And then starting with number 5, we're going to do it more like we did the addition subtraction. And I'm actually going to change this problem. So this is a new problem. And I'm going to write it up here too. 4 over 3n minus 7 over n is equal to 1 over 6n squared. So if you look at the denominators, you want to make sure that your denominators are all the same, just like we did with addition and subtraction. But these denominators, there's no factoring involved, so you just have to multiply to make them look the same. The way that you can start is by looking at the numbers at the bottom. So we have a 3 right here, and we have a 6 right here. Can we get the 3 to be a 6 by multiplying? That's a yes, we can multiply by 2. So don't forget, if you do it to the bottom, you do it to the top. And let me just rewrite the problem. So now I have a 6 right here. 2 times 3 is 6. I have a 6 here. I'm missing the 6 in the middle, so I'm going to multiply it. So now I have the 6 everywhere. Now I'm looking at the variables. So I have n squared at the end, I have n in the middle, and I have n in the first one. You can't just do stuff to the power of 2. You can only multiply to get them to look the same. So for example, in the middle, I have the n. I can multiply n by another n to get the n squared. Just do it on the top as well. Same thing with the first fraction. I have an n. If you multiply it times n, it gives you the n squared. So now I have n squared here, n squared here, and n squared here. Once this happens, and this is going to apply for the next problems as well, once your denominators are all the same, you're going to ignore them. And you're going to focus on just the top of it, which for the first fraction, we have 4 times 2 times n, which is 8n. In the middle, the 7, think of it as a negative 7 because it's a subtraction problem. So negative 7 times 6 times n is negative 42n. And then this is going to be equal to, we have an equal sign and we have a 1 on the last fraction. And then at this point, you just combine like terms. So we can do 8n minus 42n, which is negative 34n, is equal to 1. And then to get the n by itself, we divide by negative 34. And that's the answer. So you don't want to change anything to decimals, just leave everything in a fraction form if you get fractions. But that's going to be the final answer for number 5. And then moving on to number 6. I'm actually going to add the problem in here. On your handout, you should already have it written on there. But we have this right here. This is what you should already have. So just like with adding and subtracting, you want to make sure that your denominators are all the same. So if you look at the bottom of these, you can factor. If you do GCF here, we have m times m minus 1. The middle one cannot be factored, and then the third one is going to be the same thing, m minus 1. And then you have the m in common, so you have to get the m minus 1 in the middle. So that's what's missing in the middle. We have this and we have this. You have to do it on the top as well. Once we have all of your denominators the same, you cancel these out and you're going to write just the top. So we have 1. This is a positive 1 that's going to get distributed. So plus 1m minus 1 is equal to 5. These cancel out because 1 minus 1 is 0. So we're left with m is equal to 5. And if you were to plug this one in to check it, we would have, let me see. Make sure you plug it into the original. You would do, I'm gonna do it down here, 1 over, make sure that you're putting your numbers in parentheses, especially if you have powers of 2 squared in the problem. So this is gonna be 5 squared minus 5 plus 1 over, this one doesn't really matter, but if you wanna just do parentheses with the 5, so you can get used to it, that's better. And then 5 squared minus 5. Then once you do that, it gives you true. So 5 is your answer here. And then 7 and 8, I also need to write in. So number 7, we have this right here. And then if you have the handout, you have a minus 1. And I guess I'll just go ahead and write it. So this is what it shows up on the handout. You want to be able to do fractions all across, so it helps if you make the 1 a fraction, so 1 over 1. You're going to factor your denominators, which is only going to be the first one. We can factor x squared minus 5x by GCF, which is x, and x minus 5. So the reason why we factor is so that you can see it broken down and you can see what's missing from other pieces. So right now we share the x in the first 2, which means we need it in the third one. So now all 3 have it. And then we also need the x minus 5 in this one. And the x minus 5 in the last one. So now they are the same denominators. We have 1x and we have x minus 5. So we can cross them out. We rewrite the top, so 1 is equal to, in the middle, x plus 7, x minus 5, you need to be doing box method or FOIL. I'm just gonna write what you should get from that, which is x squared plus 2x minus 35. And then for the last fraction, when you distribute the 1x, think of it as a negative because of that subtraction right there. So negative 1x times x is negative x squared. And then negative 1x times negative 5 is positive 5x. So you can combine your like terms on the same side. The x squareds end up canceling out. So we can have 1 is equal to, you can combine these two, 2x and 5x, which is 7x. And then you can combine, actually no, the minus 35 is by itself because there's nothing else. But then you can move it by adding it. So we get 36 is equal to 7x divided by 7. And this does not reduce, leave it as a fraction. That's going to be the final answer. Then number 8. So I'm not going to rewrite the denominators here because you should have them on your paper. I'm just going to factor them. So the bottom of both of these are the same. And once you do X method, you end n minus 4 and minus 2 for both of these. So we can see right away that we have n minus 4 in all 3. The only difference is that n minus 2 that's missing in the last one. So all of the denominators are the same. We can cross them out and we can rewrite our numerators, which we have 6 is equal to 1. When you distribute the 1, think of it as a negative because of that minus. So -1 times n is negative n, and -1 times -2 is positive 2. So get the n by itself. You can do it step by step. You can do -1 on both sides and then subtract the 2, or you can just combine these two. 1 is positive 2 is positive 3, and then you can subtract the 3. Either way, you get the same answer. So 6 minus 3 is 3 is equal to negative n. And to get rid of the negative, we divide by -1. And it does work if you plug it into the original. And then finally, the last problem. So this one, you cannot factor anything. I'm going to put the 2 over 1. So the first fraction and the third one are already the same. We have x plus 3. So we're going to put the x plus 3 in the middle one. So they're the same. This one right here in the middle doesn't change anything. So you don't have to go multiply the other ones by 1 because it's going to be the same thing. So we can cancel them out. And we end up with x plus 6 is equal to, distribute the 2, gives us 2x plus 6. And then make sure you distribute the negative, which is minus 5x minus 12. We end up with these two become negative 3x. And then we can also do the 6 and the negative 12, which gives us negative 6. At this point, move whatever you want to. I'm going to do plus 4x. Plus 3x. So that's 1x right here, plus 3x is 4x. Rewrite everything else. And then I'm going to subtract this 6. So we have 4x is equal to negative 12. Divide by 4, and we get negative 3. If we plug in the negative 3 into the original, we have negative 3 plus 6 over negative 3 plus 3. It's equal to 2 minus this right here. So the thing about this one is if you plug it into your calculator, it gives you, it says undefined, which means this answer doesn't work. And since that was the only answer that we got here, you would say this is no solution. If you got 2 answers and only one of them didn't work, then you would only choose the one that did work, and that would be your final answer.